Hello, lecture 5 electrostatic chapter adinga na gauss law to application hoi bol de wintin betang lecture hoi na so hoi la hi jong le classroom class lecture hi jong le na lecture ke pat ma sang a hi so you try to develop a habit of going through the portion the chapter na example jo NCERT textbook be khona khabe ni bem ho sim hlama sakota o class ma sang a hen na 11-12 chai nunga lecture vi na hi al chun so for you it is no problems om lo mai theina pati aji cho 11-12 an sim sai ja so ai banga first time a ve na hi chun so first it is better to have a thangwat idea nei na ding a chu chapter hoi na iti ha class ke pat ma sanga sim pa khona chi pen khu develop go ta aban la he chelai lecture holong hi iti kha ve lecture is also phalet na available revision bol ke bilang so try to go back and see all the concepts again titi lo ajong juka sai banga cho book khana ni na example JEE book JEE dinga ham ilo ni dinga ham na book khana ko dio chela question jo se jo bon and solve ko dio cho so you follow that habit pa cho na he pen je follow ta on. Okay, so chelai video hi gauss law to application na gauss law in its application involved in to hi lecture nga hi tan na khat hi ball beutin conductors pa hi ball beutin capacitors i ball masang ba khona aje chong hintin masapena chu gauss law he na dinga chu masapena chu electric flux he ngai na electric flux chu pi ha so what is flux? Flux is basically see see, suppose you have an electric field, okay, uniform electric field, it passes through a given surface area. Na surface area khar ke picho chala hai. So suppose this is an area, he chala area songa hi electric field hi tai chi cho na. So you have electric field like this. So here the product of this electric field na chala chi formula pa hai. So E into see this is the electric field, it's area vector chala na. Amani cross dot product pa cho pen so flux ke ti cho. You just understand it like that na. Iti ha simple simple language asai ding ajong na number of electric field lines per unit area ti hojong na sim thena hejong la see just remember it like this, okay? What is flux? E dot ds is flux na. So E into suppose if this area is delta s tiuta na delta s ohilo le area ni ohilo chon ds tiuta, so this quantity E dot ds, okay? Integral E dot ds adi da su integral jong ki koi jina chala hi hechi pa hi electric flux ki ti cho magnetism chapter adong kona magnetic flux ke ti kharum ke beta heche flux so piham so B dot ds chelai case ako B dot dl na heche pen hi magnetic flux ke ti ke cho chelai hem. Okay, so basically flux is what? E dot ds. What is s? This is the area. Okay, E is what? Electric field. Suppose a uniform electric field passes through a given surface area, then the electric flux through the given surface area is given by so this relation. Okay, electric field pa to area vector pa so dot product bol chu na chu electric flux ke ti cho simple ta sai ding so na. If you want to suppose if you tang gauss law in bol lang phala che pen hin ti ki ji thai ha che pen so you can also further write this as if the area is close area hela chu na, so we used to write like this E into ds. Okay, it doesn't get it flux so na. Okay, so for now aban banan chi diu ja chu tu ading a hi. So just remember like this, electric flux is what? E dot delta s. Okay. Ani na pen chu batang ama sa pen electric field hi vector hi hedo chu na. Aban la chun sila hi velo chun E hi bar ka koi chu si vector chu na, aban area jong hi velo chun bar ki koi chu. So it means that area is also a vector. Okay. Area vector ke ti chu magnitude jong nei direction jong nei chu na. Ala area direction chu pi di ha. So if you're given a plane surface na ahilo le open surface so planar surface on kepi ala chun hechi direction of area chu hoilang di ham tele it should be along the normal ti chu perpendicular to the surface area na hiti a hebdang hechi suppose planar area chula na ji hilaya area vector chu hoilang ham perpendicular to this surface, okay? Hichi lang jong thai anup le anung lang jong khuna silang jong thai chu aji just tang planar surface kha hung relation surface and area ni nei chula na, so one will be on this side, another one will be on the back side. Tang to chu area vector hi ta him cho na perpendicular to surface to chu chilang pa hi positive na la wala chun lang khalang pa hi negative di ta chu aji chu direction chu chum chum ko hon chala na hechi hoilang positive dingam hoilang negative dingham ti chu no na decide ta chu you can choose whatever you want, okay? side lang khat cho example chalaya diagram ma hevela chun chilang pa he plus kala ala chun so in throughout the whole question na question lung ke cho he chilang direction pa he plus positive takala ngai cho he example cho tang chi xy cho na chi so if I take this plus y as positive then for every chilai problem sung si sia cho na he plus y pa he positive akala ngai cho. Okay, if you take this as positive, the other direction should be negative. Okay, I have area so vector here so direction anay na depends on so if the surface area is plane na here direction of area so it should be along the normal. Okay, ani na pen so area so close ahong here pdha suppose sila example hevel hila hi bubbles koi na so this is a spherical bubble. Okay, so if you see the area is close na sphere kiti so close object chula khutile if you have a close object then area vector so hilang deha it should be along the normal hitau tho de na ai wanga chu it should be perpendicular outward hi ngai na hichi cho surface area cho normal kiti chu surface to perpendicular hi na but it should be outward to chu hichilang hi talo da so. Okay, now you only have one direction. Close surface ahong hilachun area direction chu along the normal hingai chu ke le it should be outward. Okay, so outward normal, this is for closed surface area. I have an open surface planar surface ahong hilachun it should be a normal along the normal na perpendicular to the surface. Okay, remember those 2 points. Hatile bana flux chu tang aso flux chu say cho if electric flux is perpendicular to surface then the surface khat example himping katena it's a surface khat cho che to electric field pa hi if this is perpendicular to the surface. Okay, surface to hin perpendicular hong hi la chun ipiti de ha aso area direction chu hilang tiu ta direction of area chu hilang hi tiu chulana so this is delta s. Flux formula chapita flux chu so we have said that this is E dot ds na chu piha E dot ds ki chu E into delta s into cos theta cho chalai theta hi pitina ha so in the previous formula na chalai theta pen hi pikisai na ha so this is the angle between E vector and area vector it's a dot product ne thim wala chun chin he diu cho so tang E dot ds akuna E s delta cos theta ka zia la chun theta pa chu angle between E to s hi ngai chulana. Okay, so like that to hi first case hi ha if the electric field is perpendicular to surface hi case pa hai na to chu electric field cho surface to hin perpendicular hong hi la chun angle between E to s khoi pi ha so they are pointing the same direction that means angle between them is 0 na 0 hong hi la chun see I have written here so the angle between the electric field and area vector is either 0 or 180 kasi bang area vector jun hi ta am chalana it can be also be along this side. Okay, delta s khutile masa case pa hi if delta s is along the side angle between them is 0. Okay, I want delta s sulang khalang hi chun electric field to angle chu 180 chulana. Okay, right, so this is the first point. Okay, electric field to surface to perpendicular hi chun angle between E and delta s can be 0 or 180 chu na ale this case I will chun if electric field is along the positive normal to in suppose example Japan hi positive side lautin kasi bang chu langkha lang chu positive na law wale langkha lang chu negative na law ngai na so that means this side is negative atile electric field chu if it is along the positive normal so that means if in this case both of them are pointing along the same direction then the electric field area vector angle between them is 0 so electric flux will be E delta s cos 0 to 1 chulana. So in this case you have see phi chu pi ha no but delta jang posita oh both are the same thing na E into delta s into cos 0 degree cos 0 to 1 chalana so therefore you will have this relation E delta s. I found if electric field and is along the negative normal the chu hilang side electric field ya hilang side delta s a hilena so like that also you can say hilole hilanga hi delta s ma hilanga electric field o ma la chun angle between them so piham 180. Okay, to chu chila hi 180 kapoda la chun cos 180 to minus 1 chulana so therefore you will have minus E delta s. Okay, le ani na chu piham if the electric field is parallel to the surface to chu ta hi surface khat hom na la surface khat ma to chu electric field jong hi chelangam ta so this is the electric field. Okay, I'll write here electric field Kutile surface direction chu hilang ham. So this is the surface delta S. Okay, angle between them is at ham. Angle between them is now 90 degree. You can take any surface. Na positive lang zon na thayo, negative lang zon na thayo, but in both of the cases angle between them is what? 90 degree. Okay, so 90 degree hong here cos 90 chu pi ham 0 chola na. So now if you want to write the flux here, flux chu pi ha E delta S cos 90 to 0 hilachun 0 into anything to everything is 0 na. So in that case the flux will be 0. Okay, it's a point pa him yalchi tao. Electric field to surface area khatchuna. If electric field is along the surface area, okay, in that case angle between surface area vector and electric field is 90. The case also flux to 0 tacho. So that means that surface will not produce any electric flux. Okay, will not contribute any electric flux na. The point is no. Electric flux if the electric field is making some angle with the surface area vector, but electric field is not along the surface area na. Okay, flux adding a point tempat na. Question got solved for the first question. Electric field is given. Okay, so E is beham 6 I cap. So like I z kasi I cap z cap din ito. So plus 5z plus 3k. The electric field ke na. The electric flux through the surface area. Tos area zon ke pita cho. Area cho p ke pm 30 I cap meter square. Okay, then what is the flux? Flux so hold na. So flux formula cho pita E dot delta S. Okay. I plus 5z plus 3k dot 30 into I. Okay, then is that the dot product pal koni ki bolita. I to I ju ke multiply da z to z ki multiply da k to k multiply chola na. Kutile I to I multiply da 6 3 are 18. Adang chi ko 0 ta so. Aji ju z cap k cap umlo na area here. Okay, so this is your flux. Newton per coulomb to electric field is a meter square to area na. So the answer will be 180. Okay, electric field is given by the reason electric field ki pina electric field should be so E naught by 5 3 I cap plus 4 z cap. The electric field ki pi E naught value zon ki pina E naught value should be ga put 2 into 10 power 3 to 2000 divided by 5 3i plus 4z. Okay, 5 4 are 20 hotel 400 na 400 into 3i plus 4z. No, but at 400 find the flux of this field through a rectangular surface area ke pina japan here parallel to yz plane. Khutia chuvtang yz plane xyz ne hedo cho heta x y to z na to chu parallel to yz plane khatila chun rectangle chu along the yz plane amtine cho. Okay, so the rectangle is something like this. It is along the yz plane. Here rectangle surface area so na ale hijipa direction of area cho hilang diha it should be along the x-axis. Okay, you can take any side na hijilang pa hilaw to so delta S. Hotela area chu I cap ta na la so here you're given that delta S should be so here 0.2 meter square, let's say I cap to area da cho. So here they ask you to find out the flux. Okay, therefore flux should be E dot delta S. Okay, E to be so 400 ga multiplying with na 3 4 are 1200 I plus 4 4 are 1600 Z. Okay, that's a dot product ma 0.2 into I. Okay, kutil I to I multiply ding adang si chu ZM lo na chala here. So if I multiply I and I, so I will have 1200 into 0.2 only. So you will have here how much 2 2 are 4 to 1 is 2 Newton meter square per coulomb. Okay, chichu electric flux na. Simple dot product may be here. Okay, then next question. If delta S is equals to 0, chi pi kasay na ha. Delta S zo kasi banga jo flux kiti pa hai na. So integral delta ds hita jong kiti cho chala hai. So this is also flux na. Ahilawle E dot ds hita jong flux is it. Okay, so both are the same thing. to chu batang he chi hi ipi ke senam te like closed surface ke te na jo lai closed surface azo lang close ka ti pa jo na. So here you're given E dot ds is equals to 0 over a surface area flux to 0 kite chu pite na. What is the meaning of that? See, like example ho kan pi do chu lai. Suppose I have a closed surface I na like suppose let's take a cube khat kala hote na lai. Cube pa chu xyz am cha chala hai xyz. Ale to hi chi cube pa hi value chun electric field pa hi, let's say electric field is coming like this towards the x-axis. Okay, hita hi electric field hong na constant electric field cha chala hi. So remember this is constant electric field. Ale to hi chi ka flux passing through this cube. Hi chi cube sunga flux pa hi na ga calculate go to chala hi. Ale chala cube pa hi, let's say a b naming ga bolt a b c d. Okay, and e f Z H. Okay. To chi cube hi value chun na chi cube hi flux a pass hala chun. So I have 4 faces. So 4 faces. I mean also which is ha. So first is A E H D. Chu which pen ha. A E H D top surface. Na chi pa hi top cho chi pen hi la right here top. Top face. Abana chu I have another face that is A D C B. Which pen ham front face. Okay, front face so which pen ham A D C B E. A D C B A na. So front face is abana chu you have another one that is B F Z C. Chu bottom face. Okay, bottom face. It's like bottom face pa which ham here B F Z C. Okay, this one is the bottom face. Abana khatto khatsu piham E H okay, right here E H Z F chichu piham back face na back face chu piham E H Z F. Okay, E H Z F ko tele chalai face ka hinzi li ho hai na ibola ka ham tele betang. So if you look at the top face, okay, the electric field is passing along the face. Okay, along the face achi chula na. Similarly, along the front face jong electric field is along the face. Okay, the bottom face also chula bottom pa jong electric field is along the face. Abana back face pa jong na. So electric field is along the face. Azawa electric field along the face ahi phalachun bikatia. See, if electric field is this, normal chu hilangham area vector chu it is like this. Okay. Khotile chalai pa hi perpendicular chalana. Cos 90 is 0, so flux is 0. So in 4 faces, so here the flux due to all of these faces is 0. It's all those yading I flux pa hi na 0 tacho. Okay. Khotile they will not contribute na. Ale pp kivana to hi. So this face, the left side face and the right side face. So then evaluation, the face is perpendicular to the electric field. Okay. If you want to draw the area vector on the right side, right face I evaluation hiti lang hi area vector chiso. Outward na hi ngai na outward. Lang khala khu area vector hiti chi ngai. So this is delta S. Okay. Left side evaluation electric field hui lang cha. Electric field is along this side. Okay. Khutile left face ading hi angle between electric field to area vector chu 180 hungi na. Right face hi angle between electric field to area vector chu 0 degree hungi na lai. Okay. So you keep in mind those points if you would not dot no vazala not dot velang na. So I'm going to do it directly here. Okay. Kutile total flux chu pidi. So now total flux is due to flux on the left side plus flux on the right side. As the flux due to top, bottom, front and back is 0. Okay. So ila lauta so to here. So kutile left side ading akas iding alasun. So let's say this cube has a side of A tivte na chi. So side A tivte. It's a side A and left side face A, E, F, B na. Flux area into electric field into area na. Electric field to E laut. So E into area to A square. Cos is at the cos 180. Left lang pa na. Okay, so here electric field is this one. Khat lang pa area vector to na. So this is electric field. Angle between them is 180. Ale zil lang pa ko lale. So zil lang ko. So E into A square into cos 0 degree. aji chu zil langa chu area vector hi cha chia bana electric field long ta chi chula na so angle between them is 0 tun value put velanga solve la chun za di ha so here E is square cos 180 so minus 1 chula na so here you'll have minus plus E is square. Okay, I'll try to is that the so this is 0. Okay, it's like a sanum the total flux evaluation due to this cube total flux is that finally we get 0. Okay, it's another way of saying this is na ga observe electric field line ga observe so whatever electric field lines going into the closed surface, every electric line that is going into the closed surface will come out. Okay. Now, every electric field line that is going into the solid, the closed surface comes out. It's a case on here. In every case, flux is 0. So here I'll tell you the answer directly. The answer is the number of flux entering the surface must be equal to the number of flux leaving the leaving it. Na line lose electric flux line lose na. So in that case the flux will be 0. Okay. He proof the banga example ka hin bol da na. Chita bang question jong hin solve the so jong phale. Okay, then that is the question. Abana 2. Find the flux of electric field through a spherical surface of radius r, charge kpia. So you're given a sphere. G is spherical surface na. Radius to kpm, radius to r kp. Due to a charge of G charge kp na. So this is the charge. At the center, center so 10 power minus 7 coulomb is placed at the center. Another charge is equal charge is placed at 2r distance away. So this is 2r. So here you have the same charge. Question to what is the flux? Flux at each other. His question ko solve no na. His concept halani jai ko na learn you na. To chu vitang hiji thai surface ka nei chona charge kha chopa la ka hin ko ya la chun azolam pha kan sai dia so due to this charge okay what is the flux through this surface value chun jok sai pen chopi ha line lu jo se chu apod wala chun so flux to 0 ka ti chula na same thing here so whatever line is coming from this charge okay to the surface na charge akona line hun jo se chu abon chang ya pod also ke chula right. So in this case, due to this plus charge, okay, due to this plus charge, the flux on this closed surface is 0. Apan nom no da flux a contribute lo na. So if a charge is, remember, if a charge is outside a closed surface, it will not contribute to the electric flux of that closed surface. Na kutila chila ya polangam pa si. When electric field line goes like this, every line coming from the charge, so it goes out. Na chicha flux due to this is 0. Okay. You consider load you tajo chipai. Ale to chon sungam pen pa khu velo chon asunga para hi electric field lines ang poda la chon so all of them are passing through the surface ra. Asunga para ang pod bachula chipen hi. Okay. So now you can consider this one. Flux to bidding ham la hi. So electric field into area chula na. So at this point on the surface electric field za diha la hi. Due to point charge to kq by r square chula na chila hi. Charge also put level charge to the kpm k to 9 into 10 power 9 charge to that ham 10 power minus 7 kq by r square radius to piha value kpilo r kp na so this is r square. Okay, he electric field khutil flux to piham flux to so electric field into area. Okay. Suppose confusion om nonang achona hilai tang hilai e dot delta is cos 0 degree cho chila ibola 0 degree hamitile hi beta electric field cho ji chola na aban area vector cho hilang area vector also perpendicular to surface so both of them are along the same direction this is angle between them to 0. Okay, so e to that ham achunga ka ji pa he 9 into 10 power 2 na minus 7 to plus 9 gom na 2 so divided by r square area of spherical surface ke pichula na area of sphere cho pm 4 pi r square so 4 pi r square kutil r square gets cancel out remaining cho pi ham value put vilang solve le chun na chala hi so 9 into 10 power 2 into 4 into 3.14 okay so if you solve this you'll get approximately 113 okay 113 into 10 power 2 na ilo 1.13 into 10 power 4 okay newton meter square per coulomb to flux okay okay next azo ka ball ban penjo na chala ya question example ka pi penjo let's solve one more okay to chu vela chun chala electric field constant cho chi hi ta bang question hoy na electric field constant na lang nge wala na you will always end up with flux equals to 0 okay so remember that to chu electric field chu constant hong hi lo azun example hiting aziote hitia hium cho hi chi question kan bol na hin azi chu board exam ho ke dong tin about NCERT textbook question khatom na suppose you're given like this hita hi cube khatom cho I'll just write cube like this okay he chi cube pa hi let's say side to value put you ha a ti put it na all value put it ne about let's say hi what happens is there is an electric field going through this okay E is a function of x that is given as let's say 10x plus 2 tute Newton per coulomb to hi electric field pa hi value chun constant hin talo chu chalai na x zau chu chalai ho so here x value can be anything khutele chalai hi electric field pa hai na so as you go along the x axis x changes so electric field will change okay atile chalai hi let's take value side to 1 meter lot so side is 1 meter okay then to hi electric field so this is along the x axis na chipen hi along positive x direction tute okay so I bolta bang ma chana to hi that means the electric field is like this okay so passing through like this along x axis khalini kan vel bolo ta chu ita bang hi cube hong ki pi ala na so here you see this top face bottom face front face to back face pa heavy chun electric field is along the surface along the surface hi chun flux lo den na so here top bottom front or back acho so because of these faces the flux is 0 so we will not consider them okay to flux to hilai am ding ham only in the front face and only left face to right face pa bo si ai flux meta cha okay so I bolta bang wasana to hi electric field left lang hi direct area vector hilang ha area vector chu towards the left side okay right face hi area vector hilang ham you should be towards the right side hpg ham tel area chu always outward normal ai hinga chu na close sa chu so you should be outward okay and next case electric field chu hilang ham left side chu na right side a chi chu na electric field chu khotil right side hi angle is at ham angle between delta S and E so that means 0 degree na zilanga hi velanga hi vela chun delta theta chu za ding ham theta chu 180 degree okay aji chu electric field chu chang hi za area chu chang hi na angle between them is 180 to chu flux ga khul le chun za lang pod ding ham and one more thing very important thing electric field chalai constant hi lo cho so that means it will keep on changing na kutile left face hi electric field za de ha to chu left face pa he value chun hilai x value za ha chala hi origin pass through chula na origin chu x equals to 0 chula so if you put x equals to 0 what will you get here I will have here 10 into 0 plus 2 that means 2 Newton per coulomb okay left face electric field to 2 Newton per coulomb zilanga hi electric field za ham so on this side x value is what x chu zata hitai nong wala chun you have traveled 1 meter already na so this phase lies at x equals to 1 okay this is x equals to 1 here line put leo chun is that hang poda de ham so here I will have 10 into 1 plus 2 so that means I will have here 12 Newton per coulomb this is electric field ta so now let's put these values and try to solve the total flux ka sai bang so flux due to left side plus flux due to the right side okay adang ho jo sia 0 ta flux na so E into E to pi ham 2 into area chu pi ham adang area hi ga zile delta S chu zat ha side to 1 hilachon cube hin side is square chala na so side square 1 meter square okay direction chu ki banglaw na so here 2 into delta S to 1 into cos 180. Okay, left face pa ko plus z lang ko zat ha. Electric field to 12 into area to 1 into cos 0. Okay, si value hipul lejon 2 into 1 into minus 1. Okay, plus 12 into 1 into 1. Cos 0 to 1 na. So here I will have minus 2 plus 12. So overall I will have here 10 Newton meter square per coulomb. Okay, this is the total flux due to this cube. Okay. Okay, so electric flux is here na. Abana hi we have something called Gauss law. Okay. It's like here electric flux ball pause na hong ki apply dito sa here. So masa pe ng Gauss law statement jo piham the flux na electric flux. The flux of net electric field through a closed surface is equals to the net charge enclosed by the surface divided by epsilon naught. तो जो मसा पे ना है जो जी electric flux चला ना electric flux enclosed by a closed surface जो close आहे ngay ना तो आहे जी Gauss law आहे so abale net charge enclosed by the surface sunga charge umzat pa box ju ki bang so aji jo piham tile azo isima bang jo charge so closed surface polanga hungoma la chun so due to that charge the flux is zero na chi ja chu Gauss law आहे charge polanga ma ki consider do cho. Okay then so this is the statement na jo piham integral hisla alum ki koi pa hai na so this indicates a closed surface. Okay, so E to electric field ds to area na ibola lai small d ke jang ham tele go hang pe Gauss law area ki consider hoy na Gaussian surface ke ti hoy area new sa cha so these are small surface so we put small d tichu piham so this flux is equals to so charge enclosed tichu q in ki ti pa hai na charge enclosed in so divided by epsilon chun he chala na permittivity of free space. Okay, so q in to piham sum of all the charges enclosed within the surface. Okay, E to piham sum of all the electric field due to all the charges. But electric field to charge has a polanga wanga to electric field electric field pa to area sunga to pass through chula na. So the electric field due to that charge outside also passes through the surface. Ahivanga flux to zero ahi ti thu na. Ahivanga electric field due to that small charge also passes through the surface. Chija chu electric field due to charge outside jong so na all the charges inside and outside has consider so chala him. So remember Gauss law to electric field to piham due to all the charges. Okay, abana q in to piham asungam hobo se na. Right, so chita banga so chala anu example kan pi pa he betan example him surface of balena one more thing before example surface on which Gauss law is applied. Gauss law is applied now surface pa na hisi pensu Gaussian surface jong kiti cho example chala question hi vela chon surface hi hoi chi pen ha chi pen chala na we have considered this surface so this surface is a Gaussian surface. Okay, khutila chala Gauss law ga zi go lew han ipi Gauss law to integral electric field ju ka se banga so due to all the charges. Okay, charges are like gupta na so here I will have electric field due to charge 1 E1 plus E2 plus E3 plus E4 plus E5 plus E6. So electric field due to all the charges okay into area to ds ka theute na chala area pa hai. So this would be equals to q in asunga hi pp ma surface sunga hi 1 3 to 4 ba chala na hai. So you'll have q1 plus q3 plus q4 divided by epsilon naught. He hi Gauss law ji dan cho he pen hi mel ji taw na. Okay then he ju Gauss law chang chu jana to hi Gauss law pa se apply do na question solve na. Right, question is if the flux of electric field through a closed surface is zero ju pi ke sai na ham flux chu na closed surface sunga flux chu pi zero hong ye chen pi ke sai na ham dele suppose si azo long pe example khari bol cho heta hi closed surface kharam cho na chila he let's say one charge q1 is inside another charge q2 is inside. Kutile to chu flux due to q2 is zero katia le chun chu pi ke sai na ha it means that whatever line is going in comes out na chu chu na sai chu kutel chipa chu he them ta chu. Okay, a second case chu pi ha flux with phala zero hong dia tang flux masa pe na chu charge polanga am la chun flux to zero na so there is one case when the flux is zero. Okay, if the charge is outside then the flux will be zero ani na pen chu charge tang asunga hung ma la chun flux to zero thelo chula na q inum tin na chula so flux zero means there is no charge inside here. q in 0 tinai so flux 0 hong yala so na. So if the q in is equals to 0, there is no charge inside the Gaussian surface. Chi case so electric flux pa so 0 tinai so. Okay. Hechu so huya kodang kodam tele flux is equals to q in by epsilon naught so na Gauss law so. So here if this is 0, then phi is also 0. Okay. Answer which the charge inside the surface must be 0. Okay. Next problem. 5 charges plus q plus 5q minus 2q plus 3q and minus 4q are situated as shown in the figure. तो जो figure है वो जो surface करके पी जाता है ना, closed surface करके पिया है. Charge होता है कि arrange. So question जो हम the flux due to this configuration through the surface is. Kasi so any charge that are outside, so they will not contribute to the flux. So therefore remove this. Okay. Ahi vanga so electric field so contribute how to so. Okay. So these are your q in. Okay. So these are your q in. Kutel Gauss law to gazi leo hen na tabang de ha. So Gauss law is equals to integral. So flux is what? Q in divided by epsilon naught. Na Gauss law so. Okay, so q in so piham, so plus q plus 5q minus 2q, so divided by epsilon naught. Got solved the usar hang bottom. So 6 minus 2, that means 4q divided by epsilon naught. Okay, answer which penham. So C is the correct answer. Correct answer. Yeah. Question hello picture na here mala Gauss law. Okay, next question. Two charges 5q and minus 2q are situated at the points 3, a and minus 5, a. The electric flux through a sphere of radius 4a having center at the origin. Tang alang pia chi lecture hai na. Gauss law boy ha bol diu cho as application part azong hona. A derivation head of result head of lesson direct question of velki dong ji question ke ha do base hello na. Complex that hi lo lesson. Okay, so here you're given something like this. Origin to July Lauten. Origin to 0, 0 na. Plus 5 to ham 3, a am na. So 3, a to plus 5 ma. Okay. Abana minus 2q ho ham minus 5 a, 0. Chila hi minus 2q na. Abana question to ham electric flux through a sphere of radius 4a. Hotel a sphere khatum cho. Okay, let's write the sphere something like this. Big. 4a to the okay, something like this. Here's his sphere. So question na. Sphere radius to 4a. Okay. Kutil sphere to x-axis so cut them 4a, 0 cut ding about minus 4a, 0 cut this. Okay. Na kutil sphere he got zero lesson to idea time kadum tabeta. Plus 5q pa inside asunga na minus 2q pa lesson polanga tazola. Okay. That means this will not contribute any flux. Okay, charge polangam pass na. So you will consider only the charge that is inside. That means this is your q in. Okay. Ale Gauss law to pita. Gauss law to flux is equals to q in divided by epsilon naught na. Q in to piham hilahi 5q divided by epsilon naught. Answer to 5q by epsilon naught. Okay. Next problem. C1 and C2 are two hollow concentric cube enclosing charge 2q and 3q respectively as shown in the figure. The ratio of flux passing through C1 and C2. Okay, two hin hitinga bolote. Let's try to draw it separately. Na mas apenin khalbai anyo pa hunga ji masaute. Okay, I'll try to write it. Hiche nya pa ho jana jepen hi. Hiche sunga he C1 tiu na jepen hi khat pen hu C2 alin pa ho C2. Okay, I'll try to draw the best I can. Ale to hi veda. C1 sunga he charge zanuma. Ipibam C1 sunga. Aji jo flux khuna ding achu charge in enclose hen ngai chura na. C1 sunga he pibam tela C1 sunga he plus 2 bom cho. Okay, only 2 column is there. Only 2q is there. Ale 3c sunga happy mum 2q zong 3q zong chila na. So inside this you have how much total is 5q. Okay, as you charge due to 2q electric field will pass through the outer surface as well. Okay. So anyo pa sunga hi tang 3q pa hi. So for the cube C1 3q is an outside charge. Okay, so it will not contribute. So for C1, the charge 2q is an inside charge na. So C1 sung ahi 2q ba umcho. C2 ading ahi 3q zong 2q zong ani ni ahi inside charge cho. So C2 ading ahi charge enclosed is at ham 5q na. Kutile flux due to C1 is at the hachi. So 2q divided by epsilon naught. So flux due to 2 is at the ham Japan here 5q divided by epsilon naught. Question pido ham. So flux passing through C1 and C2. Kutile C1 by C2 na. Phi 1 by phi 2 tina cho jela hi. Hichi bedang hi cho jong patia na follow di ngai cho. Hila hi through C1 and C2 ati le chun. So that means phi 1 by phi 2. Okay. Ta cho C2 and C1 ati le chun phi 2 by phi 1 hi na. A language jong hi na follow ngai cho. Aji cho option hi le chun. You have one option where you have 2 by 5, another option where you have 5 by 2. Okay. So you have to be very careful. Kudile izad ha jela hi. So 2q by epsilon naught divided by 5q by epsilon naught. To solve lesson, you'll have 2 by 5. Okay, 2 by 5 so piti ham tele 2 is to 5 tinai so. Okay, next problem. Abona flux question ngan chang so here. Gauss law ki apply na. A point charge causes an electric flux ki pina to hai. So this is flux. To pass through a spherical Gaussian surface of radius ki pina Japan here. So this is R. Center on the charge. Charge to center arm na. The value of the point charge is to hi charge ki hello so I hold na la. Okay, charge to center arm alsun. Suppose you have a sphere like this, okay. Asung hi charge na charge to q to oh. Kudule flux to ha. So flux is q in by epsilon naught. Gauss law na. So that means here we have to find out q in. As you charge to sunga da so na. So this whatever charge they ask you here, so let's say there is a q tube. So q in is basically q. Q to so flux into epsilon naught. Value na put one solve using. So let's solve that one. Flux is like minus 2 into 10 power 4. Epsilon naught to 8.85 into 10 power minus 12. Got solve lesson here. So 2 5 part 10, 2 8 are 16, 17, 1 in hand, 2 8 are 16, 17. Into 10 power is at minus 8. Okay. So minus 17.7 into 10 power minus 8. It's a penny coulomb. Na charge is also. Okay, which option? Option B. Okay, cut penny 15. So I have made a mistake. So this is 15. Okay, then next problem. A charge q is placed at the center of one of the surface of a cube. The flux linked with the cube is. We are going to learn one concept. Okay, question solved and flux question on KP question solved and hard pen na. So you have to know this one. Okay, chita bang question on KP solved and so piham. Hila have it down. So you are given a cube here. Okay, I need a cube. Can I have a cube? Okay, I don't have any cube. I'll try to use this one. Square here. Okay, and another square here. Didn't got it. Okay, then I have a cube here. To the charge so here charge to on the surface of on the center of the one of the face at each like charge cube. Atile to in charge upon in flux electric field line hungum lesson hita him jana. So on all sides, okay, on all sides like this. Okay, now it is very difficult to solve. Okay, solve than hard so solve the solve na iwan so hard so chila here. Easiest a technique to piham dang method dan ka hello dio hita bang question hung kpi lesson a technique pa na solve than possibility bolding ham the lesson. So here you have to do one thing. So the thing is, so whatever shape they give you na if I try to draw another same identical cube on this side got produce leng na here. So this is the same cube. Okay, these two are identical cube. To tang cube to his shape he close surface na I have one closed surface. Inside this I have one charge. This is your q in. Okay, it's by q in to be a q. So that means the flux passing through this total surface. Okay, So flux passing through this total surface is what? Q by epsilon naught. Na. Kutile total surface flux to Q by epsilon naught ahila chun. You see this is half of the total surface. Na. So total pa hi ni hom khen leo chun khat chu chi hong ita chu. So which the question is asking. Na. Question chun suppose e do chula na. So that means the total flux if I divide it into 2, so I will get the flux due to this. Okay. Here's the total surface is na. Total surface of flux to pm Q by epsilon naught. So if I break this total surface into 2 pieces, I will have 2 cube. So due to one of the cube, it will be half of this value. Okay. Okay. Therefore, flux due to this is what? So half of the total flux. That means Q by 2 epsilon naught. Okay. So that is your answer. Okay. Chita bang involved video question. So next question you see. A charge Q is placed at the center of the open end of a cylindrical vessel. To a cylinder na. So you see your cylinder is like this. Okay. Those open in khalang closed. So this side is closed. So this side is open. Okay. So here you have a charge Q. So they are asking you what is the flux due to this charge throughout the surface of the vessel. So whatever electric field is coming, it will passes through all of this. So due to this charge, to find out the flux due to this is very difficult. Okay, surface area surface formula, curved surface area ma, circular surface area ma. So electric field into area tana ball phala chun chipen it is like very difficult. Okay, so method ka hol ka hil pa so technique pa so na bandiu na. So now you take another cylinder, same cylinder, produce it this side. Okay, it in produce la chun hilang ni close na. So you see these two are identical. Okay, chiteni na identical. Overall he velocity pumpi velocity close one closed cylinder closed cylinder leta. So here you have one closed surface and then you have one enclosed charge. So that means due to this charge throughout the total surface is what? Q by epsilon naught. Okay, Q by epsilon naught is if I divide it into half, so total flux is Q by epsilon naught. So flux due to this side will be Q by 2 epsilon naught, and flux due to this side will be Q by 2 epsilon naught. Okay. Question chun pido ham question chun veilang pabo do na due to this. So therefore the flux will be half of total. That means Q by 2 epsilon naught. Okay, that is your answer. Okay, to hi particular question khan na specific type of question khan in solve de. So ajala him cube problem na cube problem ti dizing. Suppose I have a cube. Okay, so something like this. Okay, so this cube he closed surface. Okay, this is a closed surface. Suppose I put a plus Q charge inside. Okay, due to this charge, electric field line due to this charge it passes through the sphere. So here, due to this charge, total flux is at the. So what will be the total flux? It will be Q by epsilon naught. Charge enclosed to Q. So here, sometimes, okay, question what is the flux due to one phase? Okay, what is the flux due to 3 phase, 4 phase? Okay, then first, let's try to find out what is the flux due to one phase. Okay, so phi due to one phase. Okay, kuta chichu zat dia azo lai bol ho chu themat ga recall lo chu na zo bol ho chu tang nia khop khana la chun total flux Q by epsilon naught chu na nia ka khop khana la chun, so due to one side it will be half of total flux. Okay, chuto banga chu na total flux due to 6 phases. Tang okay, I'll do it like this. It's like total flux he pick na ji. So cube hun phase group anai chula na. So this Q by epsilon naught is basically the total flux passing through 6 phases. Okay. Now phi total so piham. So phi total is, so flux is a phi through 6 phases. Chichu piham Q by epsilon naught. If I ask you what is the flux through one phase? One phase as Zadingham, total pa who go in divide ball na, it will be Q by 6 epsilon naught. Okay, chito bang question phase is that and over na to tung zui so you can what I do total flux ako na divide lele theo. So suppose I ask you flux due to let's say two phases. Na two phases we piti na ham. So now I know the flux due to one phases. Okay, hezi khat chula na due to two phases helachun into two in bol lechun. Okay, that will be the flux due to two phases. So Q by 6 epsilon naught into 2 times. Right? That means Q by 3 epsilon naught. Here flux due to two phases. So if I ask you what is the flux due to, let's say flux through 4 phases. Now 4 phases. So 4 times what is that? Q by 6 epsilon naught. Phase group phase lium na phase khara so Q by 6 epsilon naught here lia ding also into 4 ball na that ding ham japan 2Q divided by 3 epsilon naught. Okay, it's depend he not tabanga na separate I can solve it na cube problem cube sometimes they ask you these things. Okay, technique pa to remember mensi lesson na. So due to one phase value pa to here lesson. So total flux should be due to 6 phases to Q by epsilon naught. So total flux due to one phase to that Q by 6 epsilon naught. Now due to one phase head valation, due to two phase to into 2 ball velang, due to 4 phase to into 4 ball velang, due to 5 phase of the valation into 5 ball velang. Okay, so that will be the answer. Okay, next you see a charge Q is placed at a distance of a by 2 above a center of a horizontal square surface. It's a square surface. It's a square to side to A na edge A. To at a distance of A by 2. A by 2 is charge charge of plus Q na. So they are asking you what is the flux through the surface. It's a square surface area na due to this charge flux resulting ham. Okay. So what I can do is now I'm going to create a cube here. Okay. Hitting the Tazi length cube so this is a cube side A. Okay, now I have a cube. Here's a cube I have a total flux is so due to this cube, what is the total flux? Total flux is Q by epsilon naught. Okay. Question question surface area due to this surface. So this surface is one phase of the total cube. Okay, that means flux due to this is what? So Q by 6 epsilon naught. Okay, that will be the answer. As well say na. Okay, bana Gauss law application na. Application he infinite wire to seed to cell ake bol na. Hampe ibola application see what is the use of Gauss law? Gauss law so it is used to find the electric field. Okay, electric field due to infinite wire na due to infinite seed due to spherical cell. Syllabus NCRT na. So all those three. Okay, must have to infinite wire. See, suppose I have a wire. Tahina. Charge let's say charge is plus. Okay, plus Q charge. Okay, let's say the charge distribution is lambda coulomb per meter. Lambda so this is the charge per unit length. Linear charge density so charge lambda charge per unit length lambda is equals to charge divided by L. Okay, or charge to lambda into L. Okay, so charge distribution per unit length to lambda. We have to find out electric field at a point. Let's say R distance point P here. Okay, Gauss law ki apply na surface pa Gaussian surface ke na. So we have to write a Gaussian surface. Surface so here for the wire you will have a cylindrical Gaussian surface. Okay, this surface pa na. So this will be a cylindrical Gaussian surface. So radius to R has a height part. So let's say this is L na. Gauss law Gauss law integral E dot ds equals to Q in by epsilon naught. So electric field area area chu vetang chela area cylinder ang kazil sun area chu zaram ha top surface area ma bottom surface area ma ba curved surface area am chuna top surface pa ga velo chun electric field surface area vector zo hilam ha so it is normal hitai chola na abana electric field chu iti chi ha so electric field is like this okay on all sides kutele area vector jo hilangam area vector jo chi na so if you try to see it area is always perpendicular to electric field okay is a so electric field so if it is along the plane then flux on that side that surface is zero usually na so similarly top surface to bottom surface ahi flux zero ta so okay so you will have flux only due to the curved surface area kutele curved surface area cho piham so 2 pi r into l okay abana cos theta chu zat ham the curved surface evaluation area chu chilanga chi chola na electric field zon chilanga chi za angle between them is 0 so cos 0 is 1 okay abala charge chu piham so charge chu chipen himangla chon lambda into l ta ka ji thei cho chela he so lambda into l divided by epsilon naught so ll gets cancelled out electric field is arang podam so lambda divided by 2 pi epsilon naught into r okay so this is the electric field due to infinite wire. So next you have infinite sheet. Infinite sheet to choose something like this. Okay, it's like surface ahi charge ki koi cho jalai. So you have charge all over the surface. Khutile electric field jo hai hold do ham near the surface na at a distance of chilai jong hi r tu te na okay see so let's say here the charge is charge distribution is sigma chu piham so charge per unit area okay so because say nam the surface charge density jong kiti so japan surface I charge ang ki ko na so sometimes we call that a surface charge density if is like say ham the infinite zo na a dimension chat ki hello chula but we can calculate in 1 meter how much charge is there okay so chichu chike sai ne so per unit area in 1 meter square so charge from that pen na so that is sigma okay ale chala hi Gaussian surface it is idu ham so here same thing you take circle here cylindrical Gaussian surface okay that's adung la jong ki produce ding something like this na area so let's say pi r square hamang pautin so let's say here area is a okay dang plane a hete khat chun he du chu chilai plane surface a here chun if it is a plane surface you have two area na so front side back side okay khutile Gauss law gasila chun integral e ds equals to q in by epsilon naught chala na Gauss law chu so we have to find out electric field area chu pi ha so area chu charge so hoila ma helang side ajong ma back side ajong ko charge chala na you have two area here okay a plus a so this is equals to tang chala hi charge per unit area sigma chu pi ham charge divided by area na kutile charge chu pi ding ham sigma into area azola lambda into l is tabang ba so here charge encloses sigma into area divided by epsilon naught chika solve legend e into 2a should be equals to sigma into a divided by epsilon naught a to a cancel na he so remaining to ham e equals to sigma by 2 epsilon naught okay japan he pm so this is the electric field due to infinite sheet okay sigma by 2 epsilon naught Hichi derivation ho import exam mane apai mo na eba final answer pa he so this one is important for entrance exam okay azola nga infinite wire pa chu pita so 2 pi epsilon naught into r heza to chu chalai hi sigma by 2 epsilon naught okay hotle chaina pending a spherical cell okay spherical cell hollow sphere tina chu cell so hollow sphere okay hotel hollow sphere khat amal charge jo hoila yam de ha it will be on the surface na okay radius to r tu tena la ye radius r So let's say I want to find out electric field at 2 points. So one is inside, another one is outside. Okay. So inside point to P la. So point P at a distance of x, I want to find out electric field. Inside first I will draw a Gaussian surface. Okay, let's say this is the Gaussian surface. Inside so let's say here inside. Inside Q in here. Gaussian surface charge is charge so the charge lies on the outer surface of the sphere. Okay. Gaussian surface charge so field is charge Q in is 0, so therefore the flux is 0. Okay. Now, electric field is 0 see. Gauss law electric field into area of this spherical surface spherical surface radius r na. So I will have here E into 4 pi x square, 4 pi r square area sphere. So this is equals to Q into 0 by epsilon naught. So that means you will have E equals to 0. Okay. Spherical surface inside also electric field 0 na. Let's take another point outside. Point Q law na. So let's say distance of r tu r distance I Gaussian surface ka draw la chon ita bang de ha. So I will have something like this. This is spherical, okay? Spherical Gaussian surface. So B is outside. Q in is that halai here. So what is Q in? Suppose total charge on the sphere is plus Q na. Charge those to Gaussian surface all the charges are inside this Gaussian surface. Q in to PM Q in is Q itself. Okay, whatever charge is placed on the sphere itself. So that means E into 4 pi r square should be equals to Q by epsilon naught. So how much will you have? So Q by 4 pi epsilon into r square. It's mukha to kilo na ji. So E to pm KQ by r square. Okay. So what is the meaning of this? So example here points are plus Q at a distance of r. Here electric field is at the KQ by r square. Compare so same. Electric field due to point outside. Okay. For a sphere is KQ by r square. Electric field due to point charge at the distance r is KQ by r square. Electric field so that means for a point outside, okay, I can consider this whole thing as a point charge. Sphere I can consider this whole sphere as a point charge, which is situated at the distance of at the center. It's a sphere pa center point charge point charge so plus Q charge okay. So at the distance of r, electric field will be KQ by r square. NCRT so for a point outside, I can consider this whole sphere as a point charge. Formula formula sphere to point charge okay. Okay, then sometimes graphs on sphere graphs it bang de. Suppose I'll try to draw it here. Okay, something like this. Inside to electric field 0 na, so till the radius. Okay, radius electric field 0 so after radius, outside radius should be KQ by r square. E is proportional to 1 by r square. This is parabola. Something like this. Okay. Accurate E versus R graph. Okay, then application part to NCRT syllabus so the revision formula, final formula okay, then question solve it so there will be Gauss law. First question: a spherical conductor of radius kipia has a charge on kipina, so charge is given distributed uniformly. That magnitude of electric field at a point 15 centimeter. So this is what they give R. So this is radius. Radius of sphere should be 10 centimeter na. A electric field so here 15 centimeter. Okay. So at a point P, charge is at kikoyam sphere achu. So 3.2 into 10 power minus 7 coulomb. Okay. Then magnitude of electric field at the point 15 centimeter. Hotile he outside spherical conductor cholana outside the pita formula cho kq by r square. Okay. So E is equals to kq by r square. So how much is this? 9 into 10 power 9 into charge so 3.2 into 10 power minus 7 divided by r to 15 cholana. So 15 into 10 power minus 2 the whole square. Okay. So I will have here 9 2 are 18, 9 3 are 27, 28 into 10 power 2. So divided by 15 square to 225 into 10 power minus 4. Okay, so here I will have 288 into 10 power minus 3, 10 power minus 1 plus 1 na. Khat pa ko chito was 10 power 5, not 4. So divided by 225. Okay. 228 by 225 here 1 point something chala na. So you keep that at like as you option I have is 1.28 abona ki bang so. So they are only interested in the power. Kutile power so piha 1 point something into 10 power 5. Okay. Here's power pa pen hina. So 9 to 7 to plus 2. That's what I plus 2. So plus 2 ako na so khat so chala na high advanced remaining to 1 na. Anu ya ko na so minus 4 ang kaltawal so total is now plus 5. Okay. So answer so piham so option B. Okay. Next one, two infinite identical charge sheet and a charged spherical body of density sigma are arranged. So correct a relation between electric field at A, B, C, and D. Point kipina is like question here. Okay, then let's find out. About manjing to ama sa point A ko view. So point A he so what I see is due to this infinite sheet, electric field will be along this side. Okay. So let's say it in surface 1, surface 2, surface 3 tuta. Electric field due to surface E1 na. Surface 1. Aban point A2 due to this na. Next to due to the sphere it will be on the left side. Due to the surface it will be on the left side. That means I will have here E2 plus E3. Okay, plus E3 E3 okay, this is E3. Next has a point B na correlation. Point B who ito kibang na. So A due to B due to 1 this side is E1, due to 2 E2, and also I will have here E3. Abana C. C na khula C na who it is due to this, it will be along this side. Due to this, it will be along this side. And due to this, it will be along this side. So plus charge, electric fields away from the charge. So here I will have due to E1, okay, due to E2, and due to E3. Finally D. D na kulale. So D na na. So that means you'll have electric field along this side, along this side, along this side. E1, E2, to E3. Atil option hai evaluation comparison ngan chang chuna cho he. Okay, we are comparing A and B, we are comparing C and D. Okay. Ale option hai evaluation equals to zaunam cho he. So let's see whether they are equal na. A to B ke bangam, C to D ke bangam ga bhe ta. Okay, khutile A to B compare lew hen. Due to infinite C to piha sigma by 2 epsilon naught. Okay. Sila evaluation R rank depend locho. So it does not depend on the distance of the charge from the surface. Sila A to B evaluation is the surface apara A gamla jojo na B hinai jojo. But both of them will have the same electric field due to this surface. As is a formula for sigma by 2 epsilon naught. Okay. Electric field depends only on sigma. Na charge distribution jo gibang sila A to B acho. So we have that they are from the same surface. Okay. So due to surface 1, electric field due to A and B are same. Okay, so 1 pi ka cancel da cho. Kipang cho. Okay. Ani na pen chu S3 pa jong evaluation electric field due to the third surface S3. S3 pa jong is seed chu na infinite seed chu. So formula is sigma by 2 epsilon naught does not depend on distance. Chija chu E3 jong he kipang ani ni hona na. Kutile it will be decided by E2. Ale E2 chu piha due to spherical surface chu E is equals to kq by r square. Okay, now E is inversely proportional to 1 by r square. Ti chu r square alit chana chu E value chu niau ti nai chu. Agamthla chana chu electric field niau na. Kutile A to B hi value chun, so A pa hi sphere kuna nai zo chula na. So B is further, so electric field at B is lesser than electric field at A. Okay, here's the conclusion chun derived theo ngai chu. So therefore here electric field due to 2, electric field 2 due to A is greater than electric field 2 due to B. Kutile overall chu E chu lin jota chula na chila hi. Okay, do you have any options on that? First part wrong ke bang talaw na. Second part wrong di talaw. So third and fourth are correct. Okay, let's see. A chu greater than na to chu C to D ga avyo to. C to D I vet vala chun. Again, due to S1 and S2 is ke bang so. So here due to the surface 1 at C it will be sigma by epsilon naught at D also. Kute 1 ke bang infinite C chu 3 zong na 3 zong ke bang. Kutile 2 pa khap ta. So spherical cell pa hai. So D is closer. Okay. So D is closer and C is farther away. This is also required. So electric field due to 3 2 zo na. 2 due to C should be less than electric field on 2 due to D. As you D to nice also from the sphere in compared to C. Okay. So do you have any option? Last option is equality na. So last option is also wrong. Okay. So they are not equal. C to less is also. Okay. Option is C. Okay. Then final question. Last one. Match the following. Electric field inside distance r from the uniform charge cell with surface charge density radius. See, I'll just try to draw. Cell khatum chana la hi. So this is a cell radius to r kpa sigma kp na chala hi. Masa pen so piam field inside kiti cho jiven inside a charge cell. Inside a cho pita electric field cho 0 hilong na chala hi. Okay. So that means A will point to 3. 1, 2, 3. Okay, you have only one option, C. Na ita jo direct answer na tik theo so chu using answer cho. If you want can see the rest also. Okay, adang si ga ball the ball theo na. Ani ne pem electric field at a distance r greater than 0 from uniform infinite plane sheet. Sila na. C da jo pita sigma by 2 epsilon naught cho na. So it will be 2. So B is equals to 2. Okay. Okay, next outside pa hai na. So outside pa jo pi ha. So if you have a point outside, so kq by r square na. So batang sigma jo pi ham charge divided by so area of 4 pi r square. Okay. So from here charge is what? Sigma into 4 pi r square. Hita hai na. Hichi pa hilai put velang solve la chun you'll get in terms of sigma. Okay. Tichu hiza. So and the last one is electric field between two oppositely charged infinite plane sheet. To chu hita hi plus 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 uma. Okay. So hita hi minus 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 na. So at the point center so electric field due to plus pa chu hilang ham away from the charge sigma by 2 epsilon naught. Okay. Due to negative pa chu hilang ham towards the seat against sigma by 2 epsilon naught. Net chu pi de ha. So net to the sum of these two na. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Half plus half so pm sigma by epsilon naught. Okay, like that. Okay, then that is the answer. Na? So this one will be this one. So this one will be this. First part 0 has a second part 2. To gauss law to application part ho na question ka chop hom khom the kan chop hom is so next part ho capacitor langa hing lut di chala deuna chema san conductor tempa di bolong ai dia na NCRT azong om ja cho so conductors cho video khad bolti cho phal chun so we'll see capacitor ai lut masad diong ham ai lo like current electricity ai lut masad diong ham jo in fact dio Okay, then as lecture ading hi chan hi tan den gauss law to electric flux part na application of gauss law jong na. Okay, then I hope you understand how we'll do this much. Okay, thank you for watching.